So we're supposed to find the max and the min on this interval, where Mobius is saying P is the period. Okay, so the period means like how many x coordinates do you have to go until you start repeating yourself, until this graph starts making the same shape. So sine, cosine, they're periodic functions because they start repeating themselves. Look, this is one full period. Okay, because it's gone back, and you can put your finger at this place and start tracing. Your finger would be going up. The two fingers would be going up and down at the same rate. So sine of x, it starts right at the center of the wave. It goes up to the peak, to the amplitude, falls down to the lowest point. So it would be the middle point minus the amplitude, and then returns within 2 pi. So the period of sine of x is 2 pi. So this period is going to be a little bit different because of this pi over 3. The period is manipulated by whatever number is multiplying to x. Okay, so that's sine of x. We're dealing with 4 sine of x though, and I should have noted this on that last graph. Look, sine of x, it's got an amplitude of 1. Okay, because it's like there's a little 1 in front of you. That means the highest it can go is 1, and the lowest it can go is -1. So if we change this by multiplying by 4, all that does, it doesn't change the period. All that does is change how high and how low it can go. So this is our new amplitude. Okay, and then just trying to slowly reconstruct this. This -2, it's kind of inverted. That this whatever happens to x is doing a horizontal shift. If you're adding to x or subtracting from x, I should say, that's causing a horizontal shift. And -2 makes you think you're supposed to go 2 to the left, but a -2 actually makes you go 2 units to the right. So instead of starting right here at the origin at 0, 0, and then doing my sine wave, I'm going to start here and do my sine wave because of that -2. Okay, so here, let me draw it a little bit bigger where we're at. We are working on... We haven't touched the pi over 3 part yet. We put in this x -2 part. We said that's going to shift us. I don't know why I'm just using one corner of the screen here. That shifts us 2 units to the right, and we said now it's got an amplitude of 4, so we go down up to +4, down to -4. And then remember, sine usually starts right at the center, but because of a -2, we've been shifted 2 units to the right. So that's our sine wave. Or you could go backwards too, right? That's still the sine wave. Okay, so continuing to reconstruct. Right now it's got a period of 2 pi because this function over here has a period of 2 pi because we haven't manipulated the coefficient of x. This dictates what happens to the period. If there's ever a number that could multiply to x, that changes your period. The period is always 2 pi divided by the absolute value of lowercase b. And this is your lowercase b, the coefficient of x. Okay. So in this case, our b is pi over 3. So we have a little bit of fraction work to do. Our period is going to be 2 pi divided by pi over 3. So if you're dividing a fraction, I'm running out of room here, you can rewrite it as what happens when you flip and multiply, right? When we learned that a long time ago in math. If you divide a fraction, then you're flipping and multiplying the second fraction, the fraction you're dividing by. So I flipped and I changed it to multiply. Pi's cancel out. 2 times 3 makes 6. So now this function, if I put a pi over 3 here, it's now going to have a period of 6. That means it starts at 2 because of our horizontal shift, and it's going to start repeating itself at 8. It's going to start repeating itself 6 units away because of that new period that we just found. Almost done reconstructing. The last one's easy. The +8 just means you take this whole thing and you shift it up 8 units. So our final graph, kind of spilling over here, and this is kind of the long-winded version of what to answer for these 2 individual parts. We can find out the final graph by looking at our the graph we've constructed by interpreting the parts of the sine function. So at first it started at 2, 0, but the +8 means it needs to start at 2, 8. We've been shifted 8 units up. And then it does its normal sine wave. And so this is at x equals 2. We said the period was 6, so that means it should start repeating itself at x equals 8. What else do we need to say? We need to say that the highest point here is 12, and the lowest point is 8 minus 4 makes 4. And that's because of our amplitude. Our amplitude is 4. That means you go 4 up from the midline, 4 down from the midline. And then you could draw it going backwards too. Okay, so definitely a rough sketch, but that's enough to help us answer their question. The interval between 0 and p inclusive on the endpoints. P is the period. We found out the period is 6, so that's what they're asking us for. They're saying, what's the highest point on this interval? Well, if you go back to x equals 0 and then x equals 6, we might have a problem because this is the middle, but with our rough sketch, we don't know if we actually reach that middle or not. Okay, so we can test that out in just a second. Same thing over on this side too. But we know what the maximum and the minimum could be for this function. The maximum would be 12 because that's the highest this sine wave ever reaches on any of these peaks. So the maximum y value is y equals 12. We just need to figure out where that occurs for x. Okay. And then the minimum y value, actually, sorry, we also need to, here, that's not conclusively, that's not for, from our sketch, yeah, we can be sure. That's going to be y equals 12. I was going to say we want to wait and be sure, we want to plug in y equals 12 into the equation and solve. But you can be sure that we're going to hit 12 on the interval from 0 to 6 because we've captured that peak in there. Let me see what's easiest to do next. We want to find the x-coordinate, right? We want to know exactly where it hits that peak. We can eyeball it. It's looks like 3 maybe based on my rough sketch, but it's mathematics and we want to have an exact way. I think the only way we can do that is go back to the equation. Well, it's actually up here. F of x equals 4 sine pi over 3 times x. This is our equation. We know that 12 is the maximum, so plug in 12 for f of x. And then when you solve this equation, it's actually going to have an infinite amount of solutions, but we don't want the solution between 0 and 6. And think about why it would have an infinite amount of solutions, right? Because when you plug in 12, you're saying, tell me what x-coordinates would make this graph hit 12. Well, there's an infinite amount because the sine wave doesn't stop. Okay, so there will be some extra interpretation we have to do there. But if you plug 12 in for where the y-coordinates are supposed to go, then you've got a little algebraic equation to solve. So subtract 8 from both sides. It's going to give us 4 equals 4 sine all this gibberish. And then if you're trying to get x by itself, man, it's really stuck in there, right? But you can divide this 4 from both sides because that says 4 times sine of x right now. So divide both sides of the equation by 4. And then we're still trying to get x by itself. So what you can use is the inverse sine. So sine, you write it with sine. It's not to the negative first power, but inverse notation looks like that. Doing that to both sides. So skipped all that writing. So this right here, sine, the inverse sine of 1, that's saying, so the original sine function takes in an angle, spits out an opposite over hypotenuse ratio. So this one, you're putting in an opposite over hypotenuse ratio of 1. If you think of the unit circle, so in one place where you can get out 1, right up here, right? Y equals 1 is right up here. So sine, the inverse sine of 1 in radians is pi over 2. In degrees, that's a 90-degree rotation. And you can use your calculator for that too, that's fine. But just, we have pi given to us, so it's assumed that this problem is in radians. And so inverse sine of sine cancels out, leaves us with pi over 3, x minus 2. We're all done with trig now. It's just kind of a complicated algebraic thing to work through. You can divide pi from both sides. That's going to cancel out these pi's, and that's a balanced step. Right? So our equation becomes 1/2 equals 1/3 x minus 2. Let's see what's easiest now. I mean, I like getting rid of the fractions, so I multiply everything by 6. It's a balanced step, right? Just make sure you only multiply these two things by 6, not everything inside the parentheses. 6 times 1/2 is going to give us 3. And then 1/3 times 6 gives us 2. And then to finish solving that equation, that's 2x minus 4. So that's 7 equals 2x. So x is going to be 7 over 2. Okay, so 7 over 2 is the location. In other words, 3.5. That's what we needed to answer this question. And I'll just review why that's the answer here too for you, okay? We said the maximum based on our sketch of the graph was 12, okay? The maximum of this graph is 12. And we know it's going to hit that maximum somewhere between 0 and 6. So to find out one of those places, you can plug in 12 into your equation. So you can plug 12 right in here where the y values go. And then you can solve that equation for x. And that's what we did. When we did all that solving stuff, we found out that x equals 3.5. So that was close to that guess that we had, right? So that's where it reaches the maximum value. Okay, the minimum's going to be a little bit trickier. We know what the minimum is possible based on our rough sketch. Because of the amplitude, because of the vertical shift, we know 4 is as low as this sine wave could ever possibly go. Will it reach 4 on this interval between 0 and 6? It looks close, but it might not reach it. So the only way to figure that out is to do the same type of thing. Plug in, I'm going to zoom in for this one so I have more whiteboard. Plug in 4 in for y, and when you solve that equation, you're finding all the locations where we reach 4. Okay. The trick is when you use your calculator, it only is giving you one location. I think the calculator's default settings are usually to tell you just between 0 and 90 degrees for those arcsine things. See, does that make sense? I think it's between 0 and 180, because otherwise the calculator would have to spit out a formula for the infinite amount of solutions. But so the calculator tells you just one of them. You could use the period to figure out the rest of them. Just keep adding a period to that x location. Okay, so we're doing that here. Yeah, so we plugged in 4 because we want to know, we want to know where do we hit the lowest point on that sine wave. And so if you solve this equation, you got to start by subtracting 8 from both sides. So you get -4 equals 4 sine pi over 3 x minus 2. Then you got to divide 4 from both sides. So you get -1 equals sine pi over 3 x minus 2. Okay, and then you got to use inverse sine again. So think about what that means. If you use inverse sine, it's flipping the roles of x and y. Sine originally takes in an angle, spits out a side ratio. So inverse means you take in a side ratio. That means you take in the y coordinates in the unit circle, because the y coordinates are the sine values. So the y coordinate here is -1. So we can reach -1. It happens in terms of positive coordinates, because remember we're talking about positive 0 to positive 6. So we care about a positive answer here. We reach -1 when we go 3 pi over 2. So I'm going to plug that in next. And then I'm using inverse sine to both sides. So that makes sine cancel out on the right side, which is our goal, right? We're trying to get x by itself. So this right here, you could use your calculator. It's going to give you a decimal answer. 3 pi over 2 should be equivalent to the decimal answer you get. Actually, let's just see which, because remember we said the calculator only gives us 1. Let's try that. -1, we're in radians, inverse sine. Yeah, so that's 3. No, that's the negative, so that's a negative angle, right? Which is the same thing as what we have here. If you do negative pi over 2, that's the same thing as doing 3 pi over 2, right? So either one is the same angle. They're coterminals. Negative pi over 2 is the same as 3 pi over 2. So I'm going to use 3 pi over 2. You could just actually plug in your net here. Let's actually do it if you were to do the calculator way, because they're both going to come out to, well, they're going to eventually get you to the right answer, but you have to do an extra step if you stick with what the calculator gives you. Negative 1.5707. I just carry a bunch of decimals to make Mobius happy. Negative 1.570796. That's roughly what the calculator gave me. Okay, and so now since I'm in decimal land, I'm going to take pi, divide 3. I'm going to copy that. And I want to divide 1.570796, negative 1.57. I want to divide that by the pi over 3 that I have. So it's negative 1.5. And then if I'm trying to get x by itself, I can add 2 to both sides. Right, I divided this from the pi over 3 from both sides. Add 2 to both sides, so I get x equals 0.5. Okay, so it's a good thing we did that because our rough sketch showed from 0 to 6. My rough sketch was pretty rough because it looked like the minimum occurred somewhere in the negatives. We just solved and we found out that x equals 0.5 is the location for the minimum. We hit that bottom of 4 when x equals 0.5.